Hello everyone, welcome to chemistry. This is going to be lecture 2 of unit 1. We're going to be talking about temperature conversions. And I know you have talked about temperature conversions before. You've done conversions from Fahrenheit to Celsius. Maybe some of you have heard about the Kelvin temperature scale, and we will be mentioning that very briefly. For now, we'll just talk about this a little bit. So everyone knows that temperature scales are designed based off of 2 points, where water boils and where water freezes. And water does this pretty predictably. And now we know these units as being boiling point of water is 212 degrees Fahrenheit, and the freezing point of water is 32 degrees Fahrenheit. Now I have to make my little, I don't know how to do this. Let's see, I can't go font directly, but anyways, that's a degree symbol. Now, where did the 212 and the 32 come from? Well, somebody, Mr. Fahrenheit, had the idea that some liquids actually expand when you heat them. Mercury does this very predictably. If you take mercury and place it inside a tube and you cool it down to the freezing point of water, it will actually shrink. So Mr. Fahrenheit took his brand new thermometer with no marks on it, and at the freezing point where water was frozen, he actually marked off a spot and said, oh, that's 32, and he took his thermometer and he put it into boiling water and it heated up, and where the water actually started to boil, he marked off the spot on the thermometer of 212 and basically divided it in half and made divisions up and down and got the first thermometer. Well, 212 and 32 seem a little arbitrary, so enter the Celsius temperature scale. And everyone knows in the Celsius temperature scale that water boils at 100 degrees Celsius and freezes at 0 degrees Celsius. Remember, this is a degree symbol. I just don't know how to do that right now on this computer. Now, does that mean the Celsius scale is more accurate than Fahrenheit? No. There's just a different temperature scale with different numbers. 100 degrees Celsius is exactly the same as 212 degrees Fahrenheit. 0 Celsius is exactly the same as 32 degrees Fahrenheit. Okay, fine. So most of the world now uses, except us, of course, most of the world uses Celsius temperature scale. And again, it's no better than Fahrenheit. It's just maybe a little bit less ambiguous of a temperature scale. Just like the units of feet were decided by the Romans, and then the English decided the feet was going to be a new unit. Well, we have Celsius. Okay, where does Kelvin fit in? Well, at a certain point in time, scientists realized that there is more going on here than what meets the eye, and scientists realize that all matter, and these matter is anything from frogs to chalkboards to cars to Gatorade to chalk to car keys. Matter is composed of atoms, and atoms actually move around a little bit. Atoms vibrate. Lord Kelvin, and it was a real person, Lord Kelvin, that's not what his parents named him, realized that if you took matter and actually cooled it down, as matter cools, its atoms or molecules slow down. Okay, you got that? So as matter cools, its atoms or molecules slow. Okay, so as matter cools, atoms and molecules will slow down. Now, he realized, hey, if you're continuing to cool things down, and just kind of hold that point, is it possible to get a temperature below 32 degrees Fahrenheit? Have you seen temperatures below? Yeah, when I was in college, we had an entire week where the temperature did not get above 10 degrees Fahrenheit. Can it get colder than that? Sure. When I was a little kid, I remember a temperature of minus 40 degrees Fahrenheit. Can it get colder than that? Absolutely. Now, what Lord Kelvin speculated is that if the temperature continues to go down, that's a very, very bad arrow, but as the temperature continues to go down, atoms and molecules will get slower and slower and slower. And as the atoms and molecules are sitting next to each other, we're talking about they're barely vibrating at all, and they actually get to the point where they do something pretty incredible. They do this. Theoretically, they would stop moving. So theoretically, there's one temperature where all atomic motion will stop. And you may have heard this before. This is what we call this temperature, which happens to be negative 473 degrees Celsius, happens to be what we call absolute zero. And we say absolute zero because that's it. That is as cold as anything can ever get. Nothing can ever get colder than absolute zero. Why? Well, how much more stopped can you get than stopped? Okay, if you think about that a little bit, it should make some sense. So if we enter a new temperature scale in here, our Kelvin temperature scale, we have to put some new numbers. The freezing point of water in the Kelvin temperature scale is equal to, you ready for it? 273 Kelvin. Now, for whatever reason, and I was told this at one point, I just simply don't remember, we don't use the degrees symbol when we talk about Kelvin. I just say 273 Kelvin. The boiling point of water in a Kelvin scale is 373 Kelvin. If you notice, what's the difference between here and here? The difference is 100 Kelvin. What's the difference between the Celsius scale from here and here? It's 100. Okay? So that should help you in going back and forth. You also notice that if I want to convert from Celsius to Kelvin, I just add 273. And that's where we're going to go next. We're going to do some temperature conversions. But keep in mind, what didn't I say here yet? If you continue to go down, continue to cool, and I'm just moving my arrow over here, continue to cool down from the freezing point of water, which is actually quite warm, right, when you think about it. If you continue to cool down all the way to absolute zero, what is the value of the Kelvin scale at absolute zero, at negative 473 degrees Celsius? Well, it's equal to zero. It's 0 Kelvin. It's okay. Get it? Get it? All right, we're going to pause just for a moment. Okay, so let's talk about temperature conversions. And you may have seen these conversions written a little bit differently before. I tend to like this method. Again, I'm never going to make you memorize an equation, but if you want to convert from Celsius to Fahrenheit, so this is something where the answer is going to be in Fahrenheit, okay? You're going to take whatever you have in Celsius, and let's just have a nice round number. Let's say 100 degrees Celsius. Whatever you have in Celsius, you're going to multiply it. Those are terrible parentheses, and I apologize. You're going to multiply that number by 1.8. And then you're going to add 32 to it. So 1.8 times 100 is 180 plus 32. Let's see, carry the 115 times 7 multiplied by 85. Hold on, I'm having. Okay, so there's no surprise here. 100 degrees Celsius, remember that? 100 Celsius, what's that equivalent to in Fahrenheit? Yeah, it's exactly equivalent to 212 degrees Fahrenheit. That should make sense, right? We're converting from the boiling point of water in Celsius to the boiling point of water in Fahrenheit. Okay, now many of you have seen the expression 9/5 Celsius, and guess what? 9 divided by 5 is equal to 1.8. What about Fahrenheit to Celsius? Okay, Fahrenheit to Celsius works exactly the same way. Here's the equation. Now remember, you may have seen this as 5/9 times Fahrenheit minus 32. I just like doing it this way. If you like doing it the other way, that's fine. So let's take a nice round number. Let's say I want to convert, let's just do it again, 212 degrees Fahrenheit, and I want to convert it into Celsius. Now we know what the answer is going to be. Let's just do the math and check. So 212 minus 32 divided by 1.8. All right, I can't do 212 minus 32 in my head, so I'm just going to kind of pause for a minute. Wait, where's the pause button? There it is. Okay, 212 minus 32 is 180. 180 divided by 1.8. Now that is something I can do in my head. That is exactly equal to 100. So we have converted from 212 degrees Fahrenheit to Celsius. Does the answer make sense? Well, sure, it has to make sense, right? Well, what about Kelvin? Let's go to our friend Kelvin, shall we? Kelvin always brings out the best in people. Okay, Kelvin conversions always start from Celsius. So let's say we convert from, let's just take a nice round number. How about something that's pretty warm? How about 75 degrees Celsius? And I want to convert that to I want to convert that to Kelvin. Well, all I do is add 273 to it. Now, if you've seen this before, you might notice that this number is actually 273.15, but for our purposes right now, we're just going to kind of leave that off. So 273 plus 75, I'm using the calculator, that gets me a temperature in Kelvin of 348. And again, I don't write degrees Kelvin, I just say K. All right, sound good? Okay, last one. Imagine you had to do something a little bit difficult. Imagine I had to convert from let's go Fahrenheit temperature. How about 18 degrees Fahrenheit? Better yet, how about negative 18 degrees Fahrenheit? And I want you to do a two-step conversion, Fahrenheit all the way to Kelvin. Well, what do we do first? Well, we kind of have to convert Fahrenheit to Celsius first. So here we go. We're going to convert Fahrenheit to Celsius. So we're looking at negative 18 minus 32. And you can tell right away if I have a negative minus a negative, my answer in Celsius is going to have to be a negative. Yes, it's okay to have a negative Celsius. So negative 18 minus 32, 18, 32. That's, oops, did it wrong. 18, 32, that's 50 divided by 1.8. This is 50 over 1.8. And no, you're not in math class. You can't leave that as an answer. So if I go and divide that by 1.8, oops, sorry. It's negative 50 over 1.8. Just slapped my hand there. So we end up with a temperature in Celsius of negative 27.8. Now, that's degrees Celsius. Now I can take that and I want to convert that into Kelvin. Remember Kelvin, you take whatever you have in Celsius, in this case, negative 27.8, and we add 273 to that. Right? So this is going to give us back into the positive number region. So if I take 273 and I add it to that, I end up with a temperature of positive 245.2 Kelvin. Okay, does the answer make sense? Well, sure. But think about it like this. There's a question for you. Can you ever have a negative Kelvin temperature? Tick, 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 ding. Answers, please. Yeah, no, you can't have a negative Kelvin because the lowest you can go is 0 Kelvin. That's the coldest anything can ever get to. So you're always going to have a positive number in Kelvin. That's a good trick question. So this is the type of question you might see on a quiz or an exam. All right, this is as difficult as a temperature conversion as we are going to get. All right, make sure to watch the video and we'll take a look at some of the homework worksheets. Okay, see you.